This video is about multipath replicates of clicks as seen in data from FPODs. So what this is that if a click is traveling towards the pod through the water, it doesn't travel along a single path and arrive at the pod, but actually different parts of the sound beam will go faster and slower. And it ends up that some have overtaken others, and you end up with a whole bunch of clicks arriving at the pod. The differences in speed are because the water in the sea is never uniform. It has variations in salinity. It's evaporating at the surface. Rain is landing on the surface. Rivers are running in, etc. It's never uniform in temperature. It can't be uniform in pressure. And all these things affect the sound speed. So we can have a look at some of these wonderful results that you get from this. So here's some really beautiful porpoise data from the southwest of Britain. It's very quiet. You can see in the FP1 file at the bottom here that there's really no frequencies other than those used by porpoises. There's complete silence in the gaps between the click trains. The second panel here is showing us the frequency in the FP1 file. And what you see here is these little vertical lines of dots. Those are a number of frequencies in the multipath cluster of these replicates. This is in the FP3 file, and it's telling you how many clicks are in a multipath cluster. So it's getting up to about 15 here. And you can see that generally speaking, these high values go with loud clicks. And the top panel is the click trains, but they're colored by the train number, so you can sort of easily see which belongs to which. And you can see we've got two porpoises at once, at least two, because there's two different click trains that are going to be at very different rates, and they're overlapping in time. Here you've got click trains that are sort of duplicates, and that's because of this multipath replicates thing. I'll just show you the click rates here. Yeah, so they're going up to about 400 clicks a second here. So that's kind of a fairly typical feeding buzz there. And we will just look in on like this one here, which had the very high cluster sizes. And here you can see 6 clicks. They've each got this bunch of multipath replicates, much weaker than the original, although that doesn't have to be the case. One situation in which it's not the case is when the animal is maybe pointing at the surface of the sea and it's very calm, but the direct path goes from the animal to the pod, but that's off the axis of the sound beam. So relatively weak sound goes direct from the pod, from the dolphin to the pod, and a loud sound hits the sea surface and gets reflected down to the pod. Anyway, here we've got 93 clicks from six primary clicks, so it's 15 multipath replicates in each cluster. So that's a very diagnostic record of a cetacean. We'll see some noise later. Okay, and we can sort of zoom in here where we've got click trains overlapping. And you can see down at the bottom there the multipath clusters from one animal and the clicks from the other one that actually don't have any multipath replicates. Okay, so that's kind of nice data there. This is horrible data. So this is the Kernow classifier getting it wrong, or nearly getting it wrong, actually. What we've got here is a burst of noise, and this is a click train that the classifier has pulled out, and it's given it the moderate quality um, classification. So it's moderately confident it came from a click train source, but it was actually wrong. Um, but it only gave it a hang on, am I getting this right? Yeah, that's the number in the multipath cluster up here, and you can see it's jumping around a bit. In the previous picture where we were looking at porpoise click trains, these were generally quite coherent through the train. They stepped up and down, but they didn't jump around in quite such a irregular way. Um, so we'll change that from cluster size to species class, and it was given it was unclassed. So although this was wrong, it didn't come from a train source. It wasn't going to affect your data. Um, the thing to look at here, it was saying there were quite big clusters there. So let's kind of zoom in and see if we can see them. Um, I mean, actually, they're nothing like as neat and distinct as we saw from the porpoises, because actually they're not real multipath clusters. You know, it's said there's a loud one, probably all these belong with it, but they didn't really. Um, so, um, and another thing to notice here is that when you look at the frequencies here, there's no very definite structure there. There's a bit of sort of sense of a kind of stronger pattern here and here. And we'll contrast that in a minute with what you get from cetaceans. If we now jump forwards to look at more data, um, what we're seeing is no train was found, and again there wasn't any real structure in there. There's a little bit of a line there, a little bit of a line there. And if we go to the analysis page um, and analyze that file, we find it had 29 clicks, which are the ones we looked at, in 1.8 million clicks. So the error rate is kind of going to be 1 in 200,000 or something like that. Um, so now we're looking at dolphin click trains. And I've picked this particular view because here in the FP1 file, looking at frequency, you're seeing a lot of structure. There's kind of lines going through. There's vertical lines, which are all the clicks that appear in the multipath cluster. Um, and then there are these various lines through here. And these are arising because the multipath cluster has structure and it pulls out similar frequencies. So this is looking pretty much like the one we saw before. And these representations, this is showing you the length of the click, so that'll actually be the loudest one. And yeah, there there you have it. You know that's where the structure arises from the fact that you've got um, different frequencies being represented in the multipath cluster. Okay, so that they're incredibly useful. They tell you that you you know you can distinguish noise from cetacean um, click trains, including dolphin click trains, relatively easy by looking at these. Just as a very sort of small thing here, This actually is Heaviside's dolphin in Namibia. And looking at this, you notice down here some yellow in there. So if I zoom in on that, this is a rapid click train. There's pairs here, so probably this one is a surface echo. And like I was explaining just now, the first one can be weaker than the echo because the animal could be pointing at the surface. But then after that, you're getting in some places this much lower frequency, which is showing here. So this is again this structure that you see in the frequency display of the FP1 file. But this is supposed to be a narrowband high frequency species, but actually there is a low frequency component going along with its click. So, you know, if you wanted to study that, pods aren't really the best way of doing it because nobody will publish your work. Um, you need to be using very high sampling rate, conventional recorder and recording wave files and doing spectra and so on. But it's just to show that you can see these features in pod data. Okay, so I hope that was useful, and thank you for your attention.